All right, so what we're going to do today is we're going to take this idea and extend it a little bit and apply it to our old friends sine and cosine. Okay? So you, of course, remember sine and cosine from geometry class, right?
So it's just angles and circle unit continued?
Pretty much, yeah. Sine and cosine come from if you have a right triangle, as I'm sure you remember. If I call that angle A, B, and C, and those are the sides. Do you remember what the sine is?
It's a circle with something on it.
Oh, you mean the variable is theta. Yeah, but what would the sine of angle A be here? Opposite over opposite over hypotenuse. Okay, so SOHCAHTOA. So sine of A is, in this case, the opposite side, which is A, over the hypotenuse, which is C, right? And cosine of A would be,
Cosine
it's right here, it's the adjacent side, which would be B over the hypotenuse, which is C. Okay.
And tangent.
Well, we're gonna stick with sine and cosine mostly.
Oh yeah.
But so I'm just trying to refresh your memory. Okay, because the sine of an angle is the opposite side divided by the hypotenuse. So if this is my angle, the opposite side is the one that's the farthest away, and the hypotenuse, you all know, is the slanty side that's across from the 90-degree angle, right? So opposite is A divided by C. Okay, cosine is the adjacent side divided by the hypotenuse, which is B over C. Okay. The way that that relates to the angles that we've been doing is if you take and draw an angle on here.
Oh, really good.
I cheated. Say this angle right here. Then I can take this and make a right triangle out of it, right? Okay. And so then I can use sine and cosine and stuff to figure out either what this angle is or what the lengths of the sides are, okay? Now the most important thing for you when we work through this stuff is, I will write it in capital letters, always draw your triangle to the x-axis, exclamation point, exclamation point, exclamation point. So what I mean by that is you should recognize that you could also make a right triangle by going that way, right?
Yeah.
We're never going to do that. We're always going to the x-axis, okay? So that's a common mistake that it will help you if you avoid it, all right? And so what we're going to do is we're going to deal with angles where this thing right here is always equal to 1. Okay? And those are angles that are said to be on what's called the unit circle. Alright? So that angle comes from a circle that has a radius of 1. Okay? So this right here is my unit circle. So if I want to figure out some stuff with that angle right there, and that's the theta variable that Forrest was talking about, let's see, what do they want you to... this point right here is going to have coordinates x, y, right?
Yeah.
So this distance right here is going to be
X.
the x, because I'm going in the x direction. So that leg of the triangle is going to be x, right? And this leg of the triangle is going to be
Y.
y. Okay? Since the hypotenuse here is 1, because we're on the unit circle, if I wanted to figure out the sine of that angle, based on what we were doing on the previous page, it would be the opposite side, which is y
Over one.
divided by the hypotenuse, which is
So
1.
it's just 1.
Okay, right, so y equals the sine of theta. And I can do the same thing with cosine, except now it's going to be the adjacent side. Hold on a second. Hold on a second. The cosine of theta would be the adjacent side, which is, the adjacent side is x divided by the hypotenuse, which is 1. And so that is your cheat sheet that you should write down, which is, and then I'll answer your questions. In the unit circle, what you need to know is that x equals cosine of theta and y equals the sine of theta. And if you took a science class, a physics class, you use that quite a bit in there as well. And hold on a second, it's really easy to remember which goes with which, because x comes before y in the alphabet, right?
C.
And C comes before S in the alphabet. So if you can't remember if X goes with cosine or if X goes with sine, just think about it in alphabetical order. Okay, let's go to Lane's question first. Lane said, what's theta? Theta is a variable that you use to stand for this angle. Okay, and so I could change this angle to be something over here. And now my theta would be right there. It can change to be whatever angle I want. Okay? Kendra, did you have a question?
No.
Okay. Forrest McNeely, did you have a question a little minute ago?
No, I just wanted to go back.
Okay. And did you have a question?
Could you please go back to the first page?
To the very first page?
How do I know when it's A, B, and C like that?
We don't have to worry about that. I was just trying to refresh your memory, review this with you so you understood the opposite over hypotenuse thing.
Yeah, but I know.
But we're going to be applying it to coordinate system, and so you don't need to worry about A, B, and C. You have to worry about X and Y.
So cosine is up and over hypotenuse.
Cosine is the adjacent side of the right triangle over the hypotenuse, and sine is the opposite side over. Okay?
Go back to page 1 again.
Sine is opposite over hypotenuse.
Sine is opposite over hypotenuse. Yeah.
You back to the
We don't play them, they're out.
So they're going to want to play.
Yeah.
Yeah, now we're actually going to do it. Okay, so let's figure out the cosine.
Yeah, very good.
Okay, let's figure out the cosine of 90 degrees and the sine of 90 degrees, okay? And we are on the unit circle here. So this is a circle with a radius of, we just talked about it. Yeah, we are on a circle with a radius of 1, okay? Hold on, Lane. This is a really great time for you to actually really pay attention, because these are the kinds of questions that you're going to be asked to solve in your homework assignment and on your test. Okay? So if I want the cosine of 90 degrees, I need to find out where 90 degrees is on this unit circle, and obviously it's right there, right? Okay? So if I draw that angle, what are the coordinates of that point right there at the 90 degree line? The x-coordinate is 0, and the y-coordinate is 1, because it is a unit circle. Okay? So what is the cosine of 90 degrees? No, just the cosine, one answer.
Wait, so cosine is
It
adjacent.
says right here, x equals the cosine of theta, so x
So
is
1 divided by
x is 0, and so the cosine of 90 degrees is 0.
Wait,
Okay? I don't need to divide by anything because it's a unit circle. I would just be divided by 1, so it stays the same. So the sine of 90 degrees is 1, and that's from looking at the 90 degree angle on my unit circle. Okay?
I'm just confused on where you're getting these numbers.
So why would it just?
Where I got 0 and 1?
Where you got
No,
zero.
Yeah, why would it just be?
Because it
0
says the
and 1?
cosine of 90 degrees is x, and x is 0
How do you
at
know
90
that?
degrees.
So that's it?
Because I looked at my drawing, and this is a 90-degree angle.
Well, always be that, so
How
say
did you
that
know?
was 7 and 9.
We're going to get to that in a second.
How'd you know it went up by 1 dollar?
Because it's a unit circle, it's always
Oh, yeah,
going to
it's
be one.
always one.
Okay?
So the y is always gonna be 1.
Not necessarily, because I can move to a different place on the circle. So for example,
Don't get there.
what if I said, what is the cosine of negative 180 degrees, and what is the sine of negative 180 degrees? Okay, so now I have to find negative 180, so where do I go for that?
Down.
To the left, down, so that's going to be right here, okay? So here's negative 180, so what are the coordinates of that point?
Negative 1.
Negative 1, 0. So that means the cosine of negative 180 is negative 1, and the sine is 0, because again, the cosine is the x coordinate, and the sine is the y coordinate. Yeah.
So one of them's always gonna be 1 or negative 1.
Not if I look at a point right.
Oh, great.
Oh, you thought you could
I'm
do that.
trying to confuse.
Why is that?
Just a second.
Wait,
Only on the lines?
Yeah, only if it's on the x or y axis. Yeah,
Okay,
okay. So let's do one more easy one, and then let's do the hard ones that you guys are asking about when it's not on the x or y axis. So let's figure out what the cosine of 270 is or the sine of 270 is. So I have to draw 270 degrees. So if I start here, which way do I go? Up and left? 90, 180.
Ah!
Okay, 270. So that's 270 degrees right there. What are the coordinates of that point?
0,
0, negative 1. Okay, so the cosine of 270 is 0, and the sine of 270 is negative 1. All right, let's get crazy now.
Oh, okay.
And let's do the sine and cosine of 60 degrees. And if you picture that in your head, I guess I should have written those the other way around just to confuse you. That's bad. Hold on. Let's go cosine and sine. Keep it in the same place. Okay, if you picture that in your head, obviously those are not on the x or y axis, right? So here's where things get a little crazy. Where is 60 degrees? Okay, if I go from here, which way do I?
Up more, up.
Right up here,
Right
right?
Up there.
Okay,
Right up there.
so I am trying to find the coordinates of that
You gotta
point
draw the
right
triangle
there.
down.
Nice. So that's where I have to draw my triangle down to the x-axis. Okay?
Was it not
And
still-
now you have to remember from geometry your 30, 60, 90 triangle. Okay? So in a 30, 60, 90 triangle, if the hypotenuse is 1, which these are going to be because it's a unit circle, the short leg is, does anybody remember? 1/2, half the hypotenuse. And the long leg is the short leg times the square root of 3. Okay? So you're going to want to have that in your notes if you don't have it in your brain. In a 30, 60, 90 triangle, Katie Chapman, you're going to want to have that in your notes. Put the chemistry down. No one will get hurt. The side across from the 30-degree angle is a half, or it's half the hypotenuse. And since the hypotenuse is 1, that means it's half. And the long leg across from the 60-degree angle is root 3 over 2.
Is it always that?
Yep. Okay?
What's the 3 for?
Not it.
And not to make things totally crazy, but we also had a special
Isosceles
right
right.
triangle, isosceles right triangle in geometry.
Those two sides are the
What?
same.
So 45, 45, 91, that means that this one right here is root 2 over 2, and so is this one because it's isosceles.
Okay, but wouldn't
Wait,
you
why
be
is
able
it
to
root
figure
two?
it out if it's on
Because
the
if I go root 2 over 2 squared plus root 2 over 2 squared, I get 1.
I thought you said it was
Pythagorean theorem, this squared plus this squared has to equal that
I
squared.
thought you said it was always 3. Root 3 over 2.
For a 30, 60, 90, yes, but this is a 45, 45, 90. So they're two different triangles, so there's two different lengths. Taylor?
Okay, so that triangle is gonna be on the x-axis, don't we know how long one of them is?
Yeah, and so that's what we're about
So
to
why
do.
do we
We're
need
ready?
to know that?
Oh, because,
We're gonna get that one.
the what?
Is it always one? The long way's not always one.
If it's a unit circle, the hypotenuse is always 1, yeah.
Okay, is it always gonna be a circle in this case?
Yeah. Okay. Okay, so here we go. So let's go back here. He's got it already. So again, I'm trying to figure out the coordinates of this point, right?
Yeah.
And so this is what Mackenzie and Taylor were talking about. If this is a 30-degree angle, what is the length of this segment right here? 1/2. And if this is a 60-degree angle, what's the length of that right there? √3/2. And so since to get to here, I have to go over 1/2 and up √3/2, the coordinates of that point are going to be 1/2, comma, √3/2. Okay? Therefore, as Austin said, the cosine of 60 is 1/2, because that's the x-coordinate, and the sine of 60 is √3/2. Okay? So you're going to have to use your 30, 60, 90 or your 45, 45, 90 to figure out the coordinates of the point. And then once you know what the coordinates of the point are, you can figure out what the cosine of the
We do a
sine is.
45 one.
Yeah, I'm going to do that right now. Okay, can I turn the page?
What are you doing?
I'm going to do one more example, and it's going to use the 45, 45 one instead. Okay, so we got this set up again.
Cash.
I'm cheating.
Yeah, but you're always having right down the middle. Yours kind of like right now.
Oh, I see what you're saying. Okay.
Oh,
Let's figure out the cosine this time of 225 degrees and the sine of 225 degrees. Okay? So once again, just like with the other columns, I need to draw my angle. So this is 0.
That way.
Where's 225?
Keep going.
90.
Keep going.
180.
Stop, wait, which part?
Stop. Because if I go to 180 right here, how much more do I have to go to get to here? 45.
Just perfectly.
And so now, amazing but true, I have a 45, 45, 90 right triangle
We have a
right
1,
here.
1.
Okay? So if this is 1, what's this?
1.
Or whatever it is.
This one is √2/2. And then this one is also √2/2, right? Okay? But be careful, because what quadrant am I in?
3.
3. So they're both going to be negative. So the coordinates of this point, since I have to go to the left √2/2, is negative √2/2. And then down √2/2 is also negative √2/2. So the cosine of 225 degrees is what?
√2/2.
Negative √2/2. And the sine of 225
Same.
degrees is the same thing, negative √2.
So it'll be that every time. from
It is
45.
always going to be, until things get a little bit crazy in your life, your answers will always be 0, 1 or negative 1, plus or minus √2/2, or plus or minus 1/2, or plus or minus √3/2. All those things. Okay? I already did, it's right here. 1/2, √3/2, √2/2, 1, or 0. Okay? So
But
that's,
you said something about plus or minus.
well, because it could be positive or negative depending on what quadrant you're in. Okay? Nice catch, you saved the important stuff.
Wait, don't go forward yet.
Well, some people want me to be in
Do you have
different
that other
places.
page?
Nope.
Yeah, Forrest has to finish copying this down real quick.
Yeah, time is right. Like I'll be plus or minus. Okay, thank you.
The assignment.
Almost.
Can I show you a homework? Okay, Mom, I appreciate everything you do. You're a great mother. Thank you.
Yes, we're not class today. Push our button. Where were you at?
You know the Italian horse.
She hasn't been here all week, have they?
Oh, you're only gone one day.
It's Italian house.
That's why it's so far.
Food doesn't say what that's.
It was on one word. You don't help me.